Hey guys, this is Leah, and I am going to talk today about section 5.9 or 5-9, transforming polynomial functions. Make sure you fill in the information at the for your notes. Our learning objective today is to apply transformations to graphs of polynomials. As we're going through this, I want you to think about what some questions I would ask in a test, or what are the main ideas of the topics we're discussing, and as well as put down this in your notes. So when we're looking at transformations, this is something that we did a couple of chapters ago. It's been so long I can't remember. But I just wanted to retouch on it. When you have a vertical translation, you take your function, the entire thing, and add a value to the end of it. When you have a horizontal translation, you take your x value inside your function and minus h. So you replace the x with x minus h. So it's kind of, I think of it as inside the parentheses as a horizontal. And remember, it's opposite. So if it's minus h, so if I have, say I have x minus 4 squared, that is a translation to the right. Minus is right, plus is left. Vertical stretch or vertical compression, you take your entire function and multiply it by a constant. Horizontal stretch or compress, you take your x value and replace it with 1 over bx. And then b is your horizontal stretch or compress. And your reflections are an x-axis reflection. You take your entire function and change the sign. Or a y-axis reflection, you take your x value in your function and replace it with negative x. So we're going to look here at our first problem. What is an equation of the graph of y equals x squared or x cubed under a vertical stretch by the factor of 2? So I got vertical stretch by a factor of 2, followed by a horizontal translation 3 units to the left, and a vertical translation 4 units down. So we're going to take our equation, and we're going to start out with x cubed. Our vertical stretch by a factor of 2 will go on the outside of, because vertical stretches is a multiplication on the outside, followed by a horizontal translation. So we're going to move left 3 units. To move left, I'm going to have a plus sign in here. And then a vertical translation, that's this guy. Down 4 units. To go down, I have to be minus. Okay, so we're going to use translations to help us determine what the zeros of a function are. So let's look at our function y equals 3x minus 1 cubed plus 6. So normally, if you look at a cubic function, it is our classic swimmer shape. It goes through the origin. It goes through -1, 1, and 2, 8. So it looks like this guy here comes up. That's our classic cubic function, y equals x cubed. So what we're going to do is we're going to take these items, we're going to move it to the right. So I'm just going to start at the origin. So I'm going to move it right 1 unit, and then I'm going to move it up 6 units. 1, 2, 3, 4, 5, 6. And then I'm going to do a vertical stretch of 3. So instead of over 1, up 1, it's going to go over 1, up 3. Over 2, not up 8, but up 24. Same thing with, it's going to go back 1. Instead of down 3 at 1, it's going to go down 3. So right here. And then over 2 down 24. So we're going to have our swimmer function skinnier. What is pen? So it's going to move our 0 to -1. So we moved our 0 over to the left and up. So we moved it to the right and up 6. So our 0 is going to be around x equals -1. And then we'll check our graphing utility just to make sure, because my wiggly graph's not so amazing. Okay, so when you look at the nicely drawn graph of this function, you'll see that the red is the parent function, so that's where we start out with. The blue is the one that's moved over 1 and up 6, and he ends up crossing right here at -2.6. So I know, it's crazy. You can't see that in our on my wonky graph. So the real zeros of the function are at x equals -2.6. All right. Okay, so we're going to construct a quartic function with 2 real zeros. So in this case, our zeros are going to be 6 and 0. So what the factor theorem says is that if one item is a 0, then x minus that amount is a factor. So x minus 0 and x minus 6 are a factor. The problem is I need a quartic. And when I multiply these together, x minus 0 is just x, thank you very much, and x minus 6. The problem with having only 2 real zeros is that now I need to find some function that has a degree of 2 and no real zeros. I'm going to keep my life simple. You are definitely welcome to complicate it as much as you want, but I'm going to keep my life simple and go, this is just going to be an x squared. If I put a plus, so think about an x squared term. If I have a parabola, right now y equals x squared has a 0 at 0. But if I move it up, let's move it up 1. So it's right here. Now I don't have any real zeros, and because I don't cross the x-axis. So this is a possible quartic function, but we're going to put this in standard form because we are good citizens. So I'm going to FOIL the first 2 out. And when I say FOIL, we're not technically doing FOIL because FOIL is for 2 binomial expressions, and right here I only have one. So technically I'm distributing, but I'm going to call FOIL because it's a common terminology. Those of you guys who are really mathy and are upset with my common terminology, I apologize. So once I distribute out the x into the x minus 6, I now can actually FOIL. So I'm going to do my first x squared times x squared is x to the 4th. I'm going to do my outside x squared times 1 is x squared. I'm going to do my insides. Negative 6x times x squared is negative 6x cubed. And then I'm going to do my last. Negative 6 times 1 is x times 1 is negative 6x. Then I'm going to reorder, so I'm from highest to lowest degree. X to the 4th minus 6x cubed plus x squared minus 6x. And this is a polynomial. That's a quartic with zeros at 0 and 6. All right, last problem in this section. We're going to take a look at power functions. So not only functions, we looked at quartic, which is power 4, and cubic, which is power 3. We're going to look at where we can find any degree function and answer questions about it. So this is pretty similar to direct variation. So a power function has the form y equals a times x to the b, where a and b are non-zero. If ax to the b, y equals ax to the b describes y as a power function of x, then y varies directly with or is proportional to the bth power of x. The constant a is the constant of proportionality. Awesome. So let's look at this example problem. Wind farms are a source of renewable energy found around the world. The power P in kilowatts generated by a wind turbine varies directly as the cube of the wind speed V in meters per second. We're actually not in meters per second. We are going to look at miles per hour. The picture shows the power output of one turbine, which is 210 kilowatts, at one wind speed. To the nearest kilowatt hour, how much power does this turbine generate in a 20 mile an hour wind? Okay, so when wind is 12 miles an hour, we get an electric power of 210 kilowatts. So we are looking at a power function. So we got y equals ax to the b. We know that we are going to have a b of 3 because it says it's varies directly with the cube of the wind speed. We're going to use this information, the speed and the power, the power P. So I'm going to actually go P equals to AV cubed, where P is power. Might as well use the variables, and V is the speed of the wind. Variables that make sense to the problem. So we are given that we have a power output of 210 kilowatts when our wind speed is 12 miles per hour. So we're going to find what our constant of proportionality is so we can put together a complete equation. So in this case, 210, we divide both sides by 12 cubed. 12 cubed is, let's get my calculator out. It's 1,728. Yeah, 1,728. I'm going to go ahead and reduce this down. So we want to keep it as a fraction because sometimes things will cancel. It's a little more elegant than a decimal. When I divide these by 2, I get 105 over 864. And this actually reduces down one more time because I know 3 goes into each of these as well. So that's 288 and 105 divided by 3 is 35. So my equation is y, or let's do, let's do it in terms of power. So power equals 35 over 288b cubed. And it's asking us what's the power output when our wind is kicking up at 20 miles per hour. So this is just a simple calculator, Chug. Make sure you know how to use your Q button. Every calculator is a little bit different. So I'm going to go 35 divided by 288 equals times parenthesis 20 cubed close parenthesis equals 972 to the nearest kilowatt. So that's going to be equal to 972 kilowatts. All right, so that finishes our session for today. Go ahead and write your summary. Make sure you include your learning objective, and have a great day.